Okay, hello and welcome to our talk. Thank you all for coming. I'm Siegfried and this is my colleague Stephan, and today we will talk about Android password manager apps. We are both from Germany, from a German research institute called Fraunhofer SIT. A short announcement, as last year, we did it again, so we imported a couple of beers from Germany, actually from Munich, and we brought it to Vegas, and well, unfortunately we weren't allowed to bring it on stage, but it's safe somewhere in the crowd. So feel free to come after our talk outside the hall and grab a beer, so there are 20 cool Bavarian beers outside. Thank you. Good, so let's start with the introduction. Stephan, would you like to say a few words?
Yeah, hello, my name is Stephan. I'm also an employee of the Fraunhofer Institute, and I'm working there as a security researcher with a focus on Android security.
Thank you, Stephan. I'm Siegfried. I'm the head of the Department of Secure Software Engineering. My main research focuses on static and dynamic code analysis in order to find vulnerabilities or malicious activities in apps or in software in general. But this talk is not about us. It's about our group, our hacking group called Team SIG. We are a group of students from the university and a couple of guys from our research institute, and we meet up regularly once a week, and we sit together and we look into interesting security problems or issues. And this time we looked into password managers, and yeah, this is why we are here and we're presenting our results. So the credits also go to those brilliant students and not to us, so they helped us a lot. Good, so let's start with the motivation. I guess all of you have seen such kind of screens once you want to create a new account, for instance, on Google or something. The thing here, or the point in this slide, is that we have a policy, a password policy, which is very great. So a password has to have a certain length to be secure. It has to contain certain characters, upper lower letters and special characters, and so on and so forth, which is very great. Even a few services tell you, hey, this is a well-used password, choose another one. This is very cool. It's very great for security reasons. But so the wish is basically that we remember such kind of passwords, even longer ones. I mean, personally, I'm not able to remember such kind of passwords, even when you think about that an average user has 30 to 50 different services, and it's very hard. So password managers came up with, password generator tools came up with a cool idea to link basically the generated password to a sentence. So in this case, for instance, the generated password is x3-r and so on. And obviously the sentence you can connect to this password is Xbox 3-rope Skype Tokyo and so on. Well, it's a nice try, but even though I'm not able to connect this sentence to the password, so still this is a very big problem. So the point here is we should come up with so complex passwords, but it's very hard to remember them or to so. So how does the reality look like, at least what we figured out? In my personal environment, I have a lot of friends that make use of old school notebooks. So they store or they write down their passwords on page 120 between a very secret text or something which only they know. It's interesting, but we all know it doesn't work and it doesn't really protect your passwords. On the other side, password recycling from our current project, not this one, a new one, what we are currently working on, we see that, which is also well known, that a lot of users make use of the same password for all the different accounts. So this is also not a good idea. And then, there's also like single sign-ons, these kind of things where you have one account and when you log in, you can also log into another account. There are also security issues with that, and if you lose the first basically password, it's a problem. And this basically brings me to our topic today, the password managers. So for password manager, you have a very long master password, which protects the accounts, your credentials for Google, whatever, all your different accounts. You only have to remember the long one, and then it decrypts all your other credentials. Well, and we ask ourselves the question, at least in the mobile world, did these guys implement it in a secure way, or were there some security issues? Doing though what we did as a first step, we went on Google Play and we downloaded a couple of password managers listed by the top download rates there. First question which probably comes into your mind, why is it only 9 and why only those and why isn't there XYZ? Very easy answer. So our group usually sits together and then we split it up into subgroups, and each subgroup takes 1 or 2 apps and looks into it. So every group had an app and looked into it, and in all of the groups, every group found vulnerabilities. So in the end, well, it was not fun anymore, and after a while we stopped it and we summed everything up. So this is the reason why we didn't look into other password managers as well. So spoiler, we found 26 vulnerabilities in total, as already mentioned, at least 1 in all of them, in each of them. And well, a couple of them were already presented at a different conference, Hack in the Box, this year. But for DEF CON, we will show the remaining ones, and we also will explain our findings from a different angle. We will give you more details. Okay, so what will be the topics today? Apart from the goal of extracting the master password or the stored credentials, it's always a fun game in our group to check out the premium features, if we can get the premium features for free. So we'll talk about this in a second. Then we will talk about resetting the master password with ease. So can somebody reset the master password in order to then have access to the stored credentials? And then the second part, we will talk about breaking CAA without root, meaning having access or extracting the master password without root, or extracting the stored credentials without root for confidentiality reasons, integrity, like modifying them, and availability, like blocking it, that the user cannot log into this again. And everything is important without root. So because if it would be rooted, the device, it would be kind of much easier to access these kind of things. So our goal was to do it without root. We tackled it from 3 different angles. The first one, lost device scenario, attacker models. Basically, if I find a smartphone and I can enter it and I can then click on the password manager, for instance, is it possible for us to get access to the credentials without even entering the master password? Second scenario, man-in-the-middle attack. So if I'm sitting in the same network and they're synchronizing their credentials, for instance, is it possible to extract it? And by a third-party app. This means if I install an application on the device, is it possible that this third-party application, kind of malicious, can have access to the master password or the stored credentials? Okay, so let's get started. Premium upgrade for free. Good. So we looked into different apps, and a couple of them had the premium features. So you have to pay in order to get super cool new features. In this particular case, you had to pay $3 in order to get like export, import CVS files, theme selection. I guess you could choose between black and white. Very cool. Well, even $3 is not a lot. We wanted to try if we can still have access to these super features without paying. On the right-hand side, you see that, once you interact with the app, there is a screen like a settings in a database, which already promotes that there are more features, but you have to pay for them. So they are grayed out. In this case, auto backup, for instance, if you would like to do a Google Drive backup, you cannot do it without paying. So if you pay the $3, so then you can interact with it. And this slide is important. We will later see why. Before coming to this, a very, very brief overview about Android IPC communication, especially intent communication, for those of you who are not so familiar with Android. Well, if one application, app 1, wants to talk to app 2, for instance, in Android is usually, in most of the cases, not done directly. So it's done by a so-called intent. So an intent is sent basically to the operating system, to Android, and then Android decides which application should receive this message or the data which should be shared. How does it work? Well, application 2 has so-called filters. So the application 2 can define a filter, so the operating system knows, hey, this application is allowed, or this application wants this data if some a specific intent is sent. Of course, application 2 can also use some security mechanism to to prohibit that it receives intent which shouldn't be received by this application. And the same works, of course, if in one application there are usually more components in Android. Well, for instance, activities. If one UI wants to share data with another UI, the same principle works. So it's sent first to Android operating system, and then it's sent back the intent to the second UI, for instance. Good. The same works if you apply, if you plug in a smartphone to your, a PC to your smartphone. You can also send so-called intents to the Android operating system, and then it sends the intent to the application too, for instance. Very brief overview, we are done. But I guess this is enough information. Well, it can give more details, but it's not necessary for this talk or for the following slides. Good. So let's come back to our backup feature. So we were curious, how did they implement the backup handling? Oh, sorry, the Pro feature. And well, I simplified the code here because it was a little bit obfuscated, but the important points are here. So what they did is they stored if I paid or not into a field, so basically into RAM. And once they receive an intent with the key like paid status and the values integer 2, they set the paid value to true. And once they render basically the UI, then they enable this backup, Google Backup, for instance. So what does this mean? This means, well, if I connect a PC or any application to it which sends intents, for instance, with the adb shell command to the Android operating system, well, I can enable the features without any paying. Yeah, this is so simple. The only problem here is that it's not persistent because it's stored in RAM. So if I close the application and I open it again, it's disabled again. But what you can do is once you send the intent and you see the features like Google Drive Backup, you can then click on, yes, I would like to use Google Drive Backup. And this setting is stored persistently. So this means I once send an intent and then Google Drive Backup, I click on it and then I close the application, I open it again. It is grayed out, but it's enabled the setup. So you basically own it and you can do whatever you want. Okay, so let's talk about resetting a master password. Good. So this is a common way or common process what we found in the apps. It's not in general, what we found in those apps we looked into, how they handle the forgetting the master password or resetting the master password. So once the user forgets the master password, he clicks on Forget Master Password, and then it gets a screen showing, hey, please enter usually 4 digits. And these 4 digits are sent to your email account, which is connected to the password manager. So you open the email client, you extract the 4 digits, and you paste it into your app, and then the verification is done. If this is correct, then we come to the second stage, the security question. Well, this is predefined by the user. Well, whatever name of your mother or something like this, and if it's correct, you can reset the master password. And once you reset the master password, you have access to all the stored credentials, basically. Well, it's obvious. Good. So we will focus in the following on this particular part, so the security question. And the whole thing is from a lost device scenario. So this means we find a smartphone, we have access to it, and yeah, we will basically this is the scenario. So we started again looking into the Android manifest, which is the configuration file in Android, which contains all these intent filters or so. And we found an interesting intent filter there, which can be received, so this activity which is triggered then can receive external intents. And once you send an intent, you get basically an activity called deep link activity. Doesn't sound so fancy, we will see. So you can do this with like, for instance, with the PC again, or you can do this as well with an application. So once I send this command to the device where the application is installed, I will get a screen like this. Well, doesn't look very cool. So in this middle part, there is so the app lists all the stored credentials, the username and password of Google, Facebook, and so on and so forth. So luckily or fortunate, they didn't list the username and password immediately when we send this intent, because this would mean that you basically circumvent the authorization with the master password and you will immediately see the credentials. So at least they didn't do that wrong, which is very good. But then we saw an interesting settings at the top of the activity. And once you click on the setting, you see that there are different settings. And one of them is the reset security question. Well, this is all done without any entering password. And then, well, yeah, I can choose a new security question, whatever the name of my mother or something like this, I enter it. And it basically connects it to the email account, which is connected to the password manager application. And the old security question is basically overwritten. So what this means we own this part in the process. However, the verification code via email, this is the problem. But, well, we are saying if you find a device and you have an email account, email client, only for instance Gmail, you also can open the Gmail account to have access to the verification code, then paste this into your application, then do the security question process, and then you can reset the master password and you have access to all the stored data. So this is the only drawback here, that you have to have access to the email client as well. Good. So this was it from my part. I will now hand over to Stephan, who will continue with the rest of our findings.
Okay. Thank you, Siegfried. I will talk now about getting access to the Holy Grail, so the master secret. What is the master secret in a password manager? It can be the main password, which you entered at the beginning, which is used to encrypt your credentials. It can be just a 4-digit PIN, which protects your stored credential. Or it can also be the master key, which is used for encrypting all your data. If you can get access to this master secret, you have the jackpot. And accessing or extracting this master secret can be separated in two phases or stages. At the beginning, we have some kind of extraction process. This can be done with several ways, by backup, man-in-the-middle attacks. We will explain it in the next slides in more detail. And the second phase then would be, in some cases, the master password or the keys are additionally protected. So we have also to break this protection. And we will explain breaking this protection then in the second stage. So, okay, let's begin with the man-in-the-middle attack. There was one password manager which has a user authentication and synchronization with the backend. This synchronization was implemented by an HTTP request, but I think everybody is aware HTTP is not secure against man-in-the-middle. So the developer decided, okay, we have to protect our information. Let's implement some custom encryption or protect them by an encryption protocol. And of course, we can attack this custom encryption protocol. And yeah, it's broken by design. How a protocol looks in let's say, abstract detail, I will show here in the next slide. In reality, it's much more complicated, a lot of methods, hashing, bit shifting, but it can be reduced very easy. So we have at the beginning our post request. In the header, we have some timestamp, and the body is transferring our encrypted payload. The encrypted payload is encrypted with AES. So AES is secure, that's no problem. But symmetric cipher and communication. So what about the key? There we have different options. Everybody already knows the key. We have some key exchange, or we derived the key from a common secret. In this case, we remember to the header, there's a timestamp. The client uses this timestamp as a seed. From the seed, he generates the random key, and this random key is used as a AES. The server also has the timestamp, uses it as a seed, so he deterministically can calculate the key. So I think you can imagine what an attacker can do or what the fail is. So for who doesn't see the problem, here is again our man-in-the-middle settings. And when our man-in-the-middle attacker also can get the time from the header, he just can also generate the seed, the random key, and eavesdrop the whole traffic. Why they have done this, I don't know. This is, you see, broken by design. So how to do it in the right way. If you want to do encryption or secure communication in Android, use simply SSL or TLS. You can do this in one line. This broken implementation had a lot of classes, methods, whatever. Just look in the developer instruction you see, make an HTTPS request, and everything is secure. If you want to improve or have, let's say, stronger TLS, like pinning, also use the API. The newer Android API supports it. If you have or implement for older versions, use some reliable libraries. Also, but in the case of libraries, cross-check it because older versions can contain bugs. So another attack, how to get access to the master secret without root, would be abusing the browser file access. So at first, a short introduction. So if you look at the password manager, they offer different kind of convenience function. One function should be to automatically fill your forms. So if the user goes onto a website, let's say Twitter or Facebook, the password manager recognizes, there's some stored credentials. I will automatically fill it in and you just have to click to log in. But this is not working in reality because the common browser like Firefox or Dolphin don't provide an API for this. So what the password manager developers do, of course, it's very easy in Android. We implement our own browser. So you can use the web view. It's based on the WebKit or in the new on the Chromium engine to easily implement a browser. The advantage is that the password manager apps now have full control over its own browser and they can realize their automatic injection function. So the disadvantage is the browser is part of the password manager. So it's part of the process. So it's running in the same, let's say, sandbox. And now what can be happen if you, for instance, enter a file URL? So XML file where the password manager can store the master password. So you get it. In this case, you see, okay, there's an additional protection. The stored master password is base64 encoded, and it's also additionally encrypted. So in a few minutes, I will also show how we break this. But at first, another way to get the master secret. This is a so-called residue attack. For who is not aware about this kind of attack, I'll give at first a short introduction about the account manager. So the Android account manager is provided by the operating system. It's some kind of centralized service where application can store informations like security tokens or temporarily access tokens. It's based on a SQLite database, and this SQLite database is only accessible with system privileges. This means other applications cannot directly access this account manager database. If they want to access it, they have to use the API, and the API should ensure that there is no application accessing data of another application, so that there's a strict data isolation. So also, if you look at the developer, Android has Google wrote a few interesting information. It said you should not pass passwords or sensitive information in this account. Just use it for temporary tokens or data which will get invalidated. So also interesting that the second state, if your user credentials are protecting something valuable, so valuable, if we look in the context of password managers, your master password protecting all your credentials, I think this should be a valuable data. So in the next, I will show you a short demo how to attack this account manager without root privileges. And then I will explain the attack on a few slides in more details. So we have prepared Here, we have prepared a demo video. This is our device. On this device, I have installed one of our password manager who is vulnerable against this attack. At first, I start this password manager, and here you see I enter the master password. This is a very complex password. And I will unlock it, and you will see I have stored some my credentials for my Twitter account. But because of the complex password, I cannot keep it in mind. I use a convenient function and enable the pin locking. So I set a pin, very secure pin. So I have just to keep this pin in mind. Now there's an information of LastPass. It says for quicker unlocking. Also, the password will be stored, but it's stored in a protected way. So everything is okay. And I speed up the video a bit. So I quit the application. I restart it. And you see now I have my pin for unlocking it. So everything is fine. Now on the other side, on the left, will be a small window in a few seconds. This is from a rooted device. It just shows again the database entry from this account manager database. So you see now in this database is something stored, our email address, some information, and some encoded and encrypted information. And now the target would be to get access to this information via an app. And I will show you now how this will work. So we install now our attacker app. So again, this device is completely unrooted. So for demo, I put on the app a few buttons. If you would use an attacker app, you would hide all this stuff. So at first we register an account. There you will see an exception. What this exception means, I will explain in the slides. Then I will uninstall our target app. So I remove completely the application. So it will be uninstalled from the operating system and it's gone. Now if I click on extract the password, I will get the stored account information. And in the next step, I will also, when I click on decrypt, you will see our master password again. So this is all working without root. And how is this attack working in detail? Okay, here you see our smartphone again. You see the account manager API and our account database. So at first we install our target app. And this target app defines for the account manager API a so-called account type. Imagine this as a kind of database primary key. It's an identifier for the database row entry. We have our email address and in the case our secret password. So the application will be installed, the account manager API enters everything in the account database. There's also an association between the app and the database and the UID so that the API can identify the corresponding application to the matching database entry. Now we install our attacker app. So the attacker app can also define this account type. This is completely free. Everybody can define it. We will install it, and the account manager will now check, okay, there's another app with this account type, but the UID is not matching, okay, so we cannot enter or access this information, so we throw an exception, there's a warning. Our attacker app will catch this. Now in the next step, you saw we uninstall our target app. So the application will be removed. But the problem is now the operating system sees, okay, there's another application which is still registering this account type, but the operating system is not comparing anymore the UID, so it thinks, okay, this account type is matching to the data, so let's keep the data. And after that, the application can directly access this data without any problem. And the last thing you saw was the encryption. The encryption was very easy. Dashlane has in its application native library which has all the encryption and decryption process implemented statically, and I just put this library into my application and we're able to decrypt this. So as a hint, if you ever lost or forgot your master password, just take the library and you can decrypt it by yourself. So this brings me to the last step of our extraction process, let's say the decryption process, there are a bit of crypto and crypto fails. So at first, let's begin. What is good crypto? There was a guy, he was called Kirchhoff. He, I think around 130 years ago, he already defined how good crypto must be implemented. And he just says good crypto should not rely on the secrecy of the algorithm. It just should depend on your or on one secret. So here is a brief overview how correct encryption should work. We have some master secret. In the most cases, we have a password. This password should be augmented with some salt. Depending the salt lengths, there are different standards like the NIST who describes how long this salt should be. And this combination, there should be done a key stretching or key derivation function. And the output of this function, this builds our encryption key. And in combination with a reliable algorithm like AES, we can do our encryption and decryption. So this is, let's say, a scheme how correct or good crypto should be done. So what we find or found bad crypto. So again, we have our master password. Everybody knows this of this password manager application. You have to enter it at the beginning. In the first step, if the password is too short, they start to enlarge it by just padding zeros. There is no key stretching, nothing. The second thing is, keeping this password in mind is very complex, you saw it, so we have to store it. But storing the master password in plain text is not a good idea. Despite of this, we saw it also in applications. We don't explain it in detail because explaining a plain text password is done. So to protect it, they used static keys. And if they want to encrypt now something, they grab this stored, let's say, master key and use AES to encrypt everything. So this means now if our attacker get access to this stored password, it just somehow needs to get access to the static key. How do we get access to the static key? We found a few examples. The first one, it's just part of the app code. So we just take it out of the app and you can decrypt the master password. And with this master password, you can access your stored credentials. The second one was more complex. It was obfuscated. It was split up into parts. So they put it together dynamically. Another form we found, this was very weird. This was a kind of obfuscation. So I don't know what the developer thought about it, but he was setting up a random encryption key. The random encryption key had always the size of 9, and he implemented an own random function. So he had an array with 55 different characters, and he used a random function and grabs 9 different. So this is, let's say, the first fail, no secure random. So he uses this random key to protect his master password. So, okay, we have no static key, there's nothing in the code. But there's now the problem, we have to somehow store this key. So he implemented an obfuscation. And this obfuscated key is then stored on the device. So if our attacker gets now access to the encrypted key and to the obfuscated key and can deobfuscate it, he gets again the master password. So now look a bit into detail of this obfuscation. So as I said, at the beginning we have our obfuscated key. He had always a fixed size of the length 12. And of course, for deobfuscation, there is some black box algorithm. To be honest, we were too lazy to reverse engineer it completely because there were a lot of bit shifting and swapping and so on. So we just tried to break it dynamically by trial and error. If we could break this, we will get the random key. And of course, then with the AES, we can decrypt the master password. So we played a bit around with these keys. And if you look at the table, we modified several parts of this random key. And you see if you modify, for instance, the first and the second part of the key, the first to third part of the obfuscated key are modified. If you change the third part, the fourth of the obfuscated is changed and so on. We also saw that these parts are independent. So if we, let's say, change in the first part something, there are no changes at the end. And so this brings us to easy parts, because if we have, let's say, something of the length 3 to break, we very easily can brute force this. So we just simply build a reverse lookup table by brute forcing all random part and obfuscated part combinations. And with this with this reverse lookup table, as you can see it here, we just simply can recalculate the random key. And with this random key, we again can decrypt the master password. So what I want to show with this slide, I don't want to blame this algorithm in detail, because there are also a lot of other algorithms. What I want to say is just, if you do encryption, you do it rightly. Obfuscation is just security by obscurity. There's always someone who will break it. So don't use such nonsense if you implement security applications. There are also some recommendations how to do it right. So Android provides a secure store for credentials. Use the key store. And of course, I know sometimes developers say, okay, Android 2 or Android 3 does not support the key store. But Android 2 or 3 is not secure by design. So don't target this user. Don't support them. Use key derivation functions. There's PBKDF2 in the API. It's a bit slow, but there's already a cool open source library from Facebook. It's called Conceal. It has a bit a more faster and secure key derivation function. Don't use any static keys, hard-coded, split it up, hidden in some images or something. This is just security by obscurity. If you use AES, depending, use the secure cipher modes. Also some point where I didn't talk in detail about, but all the Android user or developer are aware of it. Password managers don't need a backup flag, because they have the backend synchronization. Their data are implicitly backup. So this backup flag just opens a new attack target to get access to your confidential data. If you have a master password or you provide a master password storage function, don't store it in plain text. So we saw this. Also the same, don't store it in the local app folder. There's always a way to get access to it. Use the key store. Here is now a short overview about all our findings. On the top you see again all the password managers. On the left row you saw the different kind of vulnerabilities we found. The first row we showed here is somehow to get access to the master password or to the PIN, hard-coded keys. The sandbox bypassing was just this browser attack. We did not talk in this talk about the side channel attacks. We presented it at Hack in the Box, but the idea was a lot of password manager abused the clipboard, an unprotected channel for transferring credentials to other applications. We had also seen there's subdomain problems. This was also very funny. The idea was if you store credentials for different subdomains, the browser did not distinguish between them. So this means if you had a domain like mysecrets.example.com and you store your credentials, the password manager did not distinguish between my security and, for instance, attacker.example.com. Data leakage was a problem of the implemented browser. Partial encryption. We also saw one password manager who did not completely encrypt all your stored information. And the broken synchronization we showed also in the at the beginning of the talk. So let's give me a short summary. Siegfried also introduced we will need password managers because of the complexity of all the passwords, and if you have to store them somehow. And we also gave different types how we attack them, all without root. If you get root access, this would be a much more worse scenario. And we also gave a few recommendations how to do it right, and a summary of all our findings. The last thing I want to mention is all the findings we had, you will find also on our website. We also announced them in a responsible disclosure process to the vendors. all our findings are fixed, but this is no guarantee that there are not any additional vulnerabilities. So this is for all Android security reverse engineers, hackers, and so on. Keep your eyes open if you find anything.
And I want to mention this is not a complete pen test what we did, so for sure there is more.
Yeah, but look into it, announce it to the vendors, because a lot of people store all their sensitive information there, and let's say protect them. So this would be the end of the presentation. As Siegfried already mentioned, we brought some beer. We can, if you have some questions, come to us. We can drink and talk about it in the hall. If you are just thirsty, you can also grab a beer. If you are too shy to talk to us, you can also write us an email. So thank you for your attention, and this is the end.